On this episode, Scott and I welcome Dick Wilkins, Principal Technology Liaison at Phoenix Technologies, to the show to discuss UEFI and the digital supply chain. Stay tuned. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Welcome, everyone, to Below the Surface, the Firmware and Supply Chain podcast. This is episode number 16. Mr. Scott Shefferman is here with me. Scott, welcome.
Hey, thanks for having me as always. Looking forward to this one. It should be good to kind of dive down deep and explore the world of UEFI with our guest.
Absolutely. I like to think I do podcasts and I try and know things, and when I don't know things, I talk to people who are smarter than me, and certainly have one of those people on the show today. And before we dig into it, Scott, just a couple of quick announcements. Below the Surface listeners can learn more about Eclipsium by visiting eclipsium.com/go. There you will find the ultimate guide to supply chain security, an on-demand webinar I presented called Unraveling Digital Supply Chain Threats and Risks, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. If you're interested in seeing our product in action, you can sign up for a demo, all that at eclipsium.com/go. I also did a really fun webinar on setting up your own hardware security testing lab, and that is out there like on our YouTube and on our website, so make sure you check that out. It was a lot of fun. Dick Wilkins is with Phoenix Technologies, an independent firmware supplier, has over 40 years of security firmware and OS experience with organizations including HP, Microsoft, Amazon, and Digital Equipment Corporation. He holds an MS in computer science from the National Technological University and PhD from Nova Southeastern University. He recently retired from teaching computer science and cybersecurity topics at Thomas College in Maine. Dick, welcome to the show.
Thank you. I'm really glad to be here.
Yeah, it's nice to have you. Also, did you serve on a couple of forums that are like very important to the state and future of UEFI? Is that correct?
Yes. My job with Phoenix is to represent Phoenix at a lot of different technology organizations, but in particular with UEFI, I'm on the board of directors. I lead the security response team from the UEFI Forum. I also work on the SBOM working group and the industry communications working group. We do marketing kinds of things for the forum.
Right. Fantastic. You and I first met about 5 years ago when you came on the Paul Security Weekly show. So it's nice to have you back on here podcasting with myself and, of course, Scott. So, Dick, I want to talk about the evolution of UEFI. Like I said, it's been 5 years since we last chatted. What are some of the major advancements that have happened, let's say, in the past 5 years with UEFI?
At this point, the specification for UEFI has been pretty stable. We've added some additional features and capabilities that, just enabling modern platforms, and done some security work here and there. But it really is refining and stabilizing the specification more than major new innovations. I guess before we talked the last time, we already had done the secure boot thing and all of that, and it's really just been improving that and providing more security for our users of the specification.
That's awesome. So I guess UEFI today, you mentioned SBOM. I know that there were some efforts to build into some of the specifications the SBOM inside of UEFI. Is there work happening in that arena?
Absolutely. We have a sub-team working under the specification team that is exploring how do we do SBOMs for firmware, how do we make that happen, what goes in them, et cetera, and do we need to make any specification changes to support that? I think the way we're leaning at this point is to more provide guidance from the organization on how to do it, what should be in it, essentially, how to deliver, those kinds of things, versus actually changing the specification to require specific features. That's not a done deal. It's an active discussion item. I guess the current hot topic is a lot of folks would like to see SBOM type information embedded right in the firmware binary. And the stuff that the compiler can add at compile time, or it can be put as a wrapper around binary images that are provided as part of the firmware that's installed on a system. There's a lot of value in doing that, in that you don't have to wait, or try and find a large SBOM data structure out in some database someplace on the web, or et cetera. You can just extract your firmware binary and look, and a lot of the information about who created this particular piece of firmware, what version is it, et cetera, is just embedded right there. But of course, firmware is loaded into a restricted resource, some kind of non-volatile memory on the motherboard, and there's not a lot of it available, so we can't use up a lot of space with a huge SBOM. So it's likely that we'll also provide a standard SPDX, Cyclone DX type SBOM structure that's downloadable in some manner or another, that has all the gory details. But in particular, in the firmware space, it seems like it would be also a good idea to include some base information right in the firmware image.
Right, because it's not really just one SBOM necessarily, because there's the base UEFI, and then folks like yourselves at Phoenix customize it, and then you're handing it off to an OEM. So there's a lot of cooks in the kitchen. Let's talk about that in respects to the SBOM. Is it being envisioned that there's one SBOM that everyone updates and kind of attests to, or are there separate ones as it passes hands?
I think where we're headed with this is then an OEM will provide an SBOM for the firmware that's on the system they sell. That percolates through the entire supply chain and has material added to it or collected by the OEM from the folks you mentioned, the OEM themselves, the firmware provider, the original open source that underlies a lot of implementations. But also, more importantly, I think, is the fact that a lot of firmware contains precompiled binaries that come from chip vendors, the Intels and the AMDs and the ARMs of the world, management code and device code. Depending on the kind of system it is, you may have BMC firmware and other things that are all part of the firmware image. And all of that needs to be included for the SBOM of the platform. So it's not just the supply chain for the traditional firmware that's modified and extended by each layer, but also these other chunks of binaries that get provided by all sorts of vendors. There are dozens of them at least, and the source code for each of those dozens comes from many places, including open source. So it's not easy. There's a lot there. And I think the earliest SBOMs that get delivered are likely to include just a high level, hey, we got this binary blob from Intel for this particular chip that's on this motherboard. If you need more details, it came from Intel and it's this version provided to us on this date. And that's all we've got. If you need more details, you need to go to Intel.
Mm-hmm.
But hopefully down the road, we'll be able to get to the point where Intel supplies an SBOM for their firmware blob, their binary blob, essentially, that can be parsed by anyone and see the whole structure of every piece of firmware that's on the machine.
That'll be a glorious day, Scott.
Yeah, question there. So, I think you were starting to maybe hit on it indirectly, but I'll try to draw it out, which is we hear a lot when we work with IT suppliers all up and down the IT supply chain that there's a tremendous amount of concern about SBOMs exposing intellectual property, trade secrets, if you will, by virtue of the fact that they're supplying everything in the SBOM. So, in that last example you gave, it behooves Intel to make you maybe have to work for a little bit harder to go to Intel to find out what's in that sub SBOM, if you will, or that subcomponent SBOM. What's your read of that when you talk with folks like chip manufacturers and OEMs, both, like on both sides of this coin, in terms of how concerned they are, or maybe some of them aren't, in terms of intellectual property being disclosed via this whole SBOM apparatus?
That is definitely a concern with a lot of folks. My take, well, let me back up and say, I think the end user that purchases a platform has a right to have openness. And they should be able to get at least the file names and versions of every piece of code that's source code that's in there. And yes, there may be some need and some level to obfuscate some detail to prevent the sharing of intellectual property. But basically, if you bought the machine, you have a right to know what's in it, down to a fairly low level of detail. Now, that opens up the possibility of maybe that level of detail in an SBOM is only available via an OEM to their certified customers, the people who actually bought hardware from them. And they're not just published publicly for anybody to evaluate, including the bad guys out there in the world. But if I bought the thing, I want to know what's in it. And I think most of the folks that are resistant at this point are just concerned that they might expose something they didn't intend to, which is intellectual property that they would want to secure. And that's perfectly reasonable. But I think as we study this and dig into it in more detail and understand what's out there, that it's likely that OEMs and chip suppliers and device firmware suppliers and that kind of thing will discover that they're really not exposing much in the way of intellectual property by releasing a detailed SBOM.
I like it.
Go ahead, Scott.
Just one other question. It's always curious someone what you in your shoes would think about it, which is, let's say we walk the dog, we could snap our fingers and say SBOM is being implemented perfectly, like all the vendors, all the exposure, perfect structure. It's already, let's you say, like loaded on the firmware automatically during, when it's being compiled, and everybody has perfect information on the device that they're sitting in front of. My question to you is, like, what does the industry feel? Because I'm in a kind of myopic cyber world where I'm worried about threat actors and bad cyber things. But what's the broader kind of vision for the value of what SBOM has for the end user, for the customer, whether that's an enterprise or just an individual at home? Why are we doing this thing, right? Like, what's the actual value in doing this, or what are some of the use cases where there would be a win if we had perfect SBOM?
Well, that's one of the why bother question is a valid one, but I think an important one to make clear to folks. If you understand what's in the computer that you bought, the firmware that's on it, you can tell potentially whether that system is vulnerable to known cyber attacks out there. This is where the VEX database comes in, that can relate SBOM data to known vulnerabilities and automate that process. there's an old joke that many years ago in the Ma Bell, the old telephone system, thought that that every woman in the United States, and note I quote that, there's really that's at the time that was politically correct. It isn't now, but every woman would have to be a phone operator because it's so complex, and to make long distance calls across the country, everybody be plugging into plug boards. And it's kind of that way here as well. Is right now we're looking at the number of vulnerabilities, the number of systems, everything else that seems like every employee at your company is going to end up in your PSERT, or your product security team, because just following up on all the potential vulnerabilities from your customers is an impossible task. There's the rate of queries from customers of, hey, I bought this thing from you. Is this firmware vulnerable? Do I need an update? Do I need a patch to this? I've heard this terrible thing in the press. And to staff up to answer all those questions from more and more aware end user customers is an impossible task. So we have to automate things. And part of that automation is finding out what's actually in the firmware on this particular system. Then if we can publish something like VEX that's been proposed, a database of vulnerability information that indicates that this particular piece of firmware is vulnerable, or more importantly, I guess, which ones aren't, and we can relate those together automatically, then an end user can just do a simple, web-based data query and get the answer they need. Is, am I vulnerable? Am I not vulnerable? Without having a huge hundreds or thousands of persons on your PSERT team answering the questions one by one.
Dick, recently I did a study of these Android devices that were being delivered to end users, and the devices already had malware on them. Somewhere in the supply chain, there was an issue, and someone was able to put malware. So it's different from vulnerability, obviously. Right now, there's some kind of either malicious code or backdoor. What can we do in the UEFI space to protect against this particular problem?
I haven't seen anything like that in the UEFI space to date, but
that's good.
On the other hand, this idea of an SBOM, identifying specifically what's in the system and where did it come from, essentially eliminates that possibility. If you really can verify that the SBOM is correct and honest and detailed in there, and you can match it up with the binary image has information that points back to the supplier information that can be then verified using software.
I like that attestation, right? That this firmware is made up of these different components. These various companies and or vendors have attested to that. And so if there is a backdoor, some kind of issue that's not vulnerability related, we can still use SBOM to trace that back to a responsible party, and hopefully find it in all things that have been deployed.
Absolutely. That's one of the other positive benefits from doing SBOM.
Of course, then we have to remove it, but it's a different podcast altogether. Let's call it. Dick, what's the talk about the relationships from your perspective, which I think is a very unique perspective between, you've got the chip manufacturers, Intel, AMD, you've got folks like Phoenix, like yourself, and then you're passing stuff off to OEMs. Let's talk a little bit about the cooks in the kitchen and the roles they play, because ultimately we get what these cooks have made as a meal, and that's what's served to us by the end user. Yeah,
it's I recently, and I'll point your viewers to the UEFI website under the Education tab. There's a papers section, and currently at the top of the list, because it's new, is a paper that I wrote with several of my coworkers in the industry from various competing companies about this whole supply chain issue. And I refer you there for the gory details. But at the high level here, it really is a flow from the chip makers and the hardware device makers, the firmware that they provide, to the firmware developers, let's put it that way. And note, I want to say here right up front, one problem we've had in the industry is we used to call this boot firmware on computers BIOS. And that's a really easy to say term, and a lot of people in the industry still use it today. But it's obviously a misnomer. BIOS hasn't existed on computers for 20, 30 years, depending on how you term the development. But anyway, more correctly, we call it platform firmware, and people have now started calling it, well, I want to get rid of that BIOS four-letter acronym. Let me change it to UEFI. So it's UEFI firmware. Well, UEFI firmware is an interface specification, not an implementation. There are many proprietary and open source implementations of the UEFI specification. Obviously, the most prevalent in clients and servers out there in the x86 space, and more in the ARM space. And we fully support Long Soon and RISC-V as well. But is UEFI, there's firmware that complies with that standard. But there are the Tiana Core EDK2 open source implementation. There's Core Boot, U-Boot, Linux Boot, and a bunch of proprietary implementations that have little to do with each other and have completely different code bases. So I just want to make it clear to everybody that we need to avoid falling into the trap of saying UEFI firmware. It's that one thing developed by this one group of people, this one supply chain. It's a multi-headed monster.
I think there's hundreds of components in there, right? Like subcomponents inside one UEFI implementation.
Well, yeah, and different sets of components. Core Boot, I think, originally started on the basis of UEFI, but branched off and is like much deviated from the UEFI standard, right?
And I'm not so well versed in the histories of the various versions all the way back, but it's just, there are many implementations out there, and we need to be very careful, particularly when dealing with the public and the general press that are not technically savvy necessarily, to call them one thing and have everybody pile on in a negative way a particular group, but when it isn't their stuff at all. It's not their responsibility. So that said, up front, there are many pieces, as we've talked about before. The silicon providers provide special initialization code for their processors and possibly microcode updates for their processors. There's management engine kind of things that helps manage their processors and control power and other behaviors of their processors. All that's microcode and macro code that's provided by the chip vendors. And today, most of that's a binary blob, like I say, which we have no visibility to. We're hoping to change that over time and allow them to expose more with the SBOM. But anyway, it's those pieces, plus all the device firmware for disk drives and network adapters and host bus adapters for fancy storage networks. And just there's an endless variety of that kind of thing that's sometimes included in the firmware image.
Mm-hmm.
And then we have the implementation of the most common, and so I'll use it as the example, is the Tiana Core EDK2 open source, which was originally developed many years ago by Intel to support the EFI before the Unified Forum was created to support this effort, and committed and donated to the open source essentially. And now it's a large project that's managed by a whole lot of people that underlies a lot of the implementations. Then we have the independent firmware vendors. It used to be IBVs for independent BIOS vendors. But that's again a misnomer. So we call ourselves independent firmware vendors now. That we take it, fix bugs, customize it, add our own value add to improve the flexibility and provide features that the OEMs want from us, et cetera. Also, some large OEMs, particularly in the server space, may have their own development teams in-house that do the same job that an independent firmware vendor does. For their specialized products that they deem it worth their while to have their own firmware developers. And they may take the Tiana Core source, or they may do their own thing. Or they may have taken an early version. Apple is the example of that. Apple took an early version of EFI, the stuff that was handed over to the open source, and modified it extensively to fit their environment. And it's still EFI standard, and they participate in the UEFI working group, but they have their own proprietary code base that has diverged significantly.
So I have a question for you. So against all of that context, right? Many vendors, each with their own customized implementations, features, even maybe security configuration settings for some of these things. In your world, what do you see as like not just your world, but you personally, where do you see the top kind of cyber threat or cyber impact potential scenarios that we have today, and then kind of going forward as we have these chip wars, a race to quantum, IT sanctions against certain nation states? This chip area is becoming like a battleground, right? Some people say it's already like the virtual World War III has already begun. And you look towards certain vendors as having asymmetrical advantages in that context of cyber warfare, for lack of better words. So we're like, what are the pressing cyber or risk challenges you see today? And then what are you worried about in the next couple of years going forward?
Yeah, that's a tough one. I don't see the chip wars going anywhere near that far at this point. We may be headed that way, I'm not sure, but I see that the most common vulnerabilities or things that are actually attacked right now are, I guess, the most common vulnerability that gets pointed at firmware has been honestly in bootloaders. It's the actually OS code. We have invalidated so many grub loaders at this point that we're running out of space to sort of cancel certificates for grub loaders. And then on top of that, with the recent widely known in the press situation with Black Lotus, that essentially was a Windows loader issue. So again, we're into the software space, not so much into firmware. But this is a firmware talk, so let's go a step down. And I would say that the largest attack surface that's been successfully compromised to date have been OEM and IBV modifications or improvements or extensions that weren't well thought out. or well designed. And
Mostly
I think
set variable calls, right? That's really what it comes down to.
yeah, it's things like, well, there are things that are currently out there that I really can't talk about right now, but it's add-ons and enhancements and features that people try and add to the base firmware to make it better for the customers, and I'm all for that. But as the folks at CISA called us out recently on, we as an industry of firmware developers at all of those levels in the supply chain need to be very careful that we're using secure design practices and implementation practices on all of our firmware. Generally, the industry has been very good on that, but we're not there. It's not as way, and secure by default also is important. I think we're pretty good on that, but again, we're never perfect, and when you're not perfect, there's opportunities, and of course we never can be 100% perfect, but the better we get, the less vulnerabilities we give to the bad guys to attack us.
So, one thing that I noticed when I was speaking to folks from Intel was, and I believe, Dick, you at Phoenix are probably in the same boat, that you design and develop like your piece of it, and you put security features in there, and then you hand it off to the next link in the chain, as it were. Sometimes those security features aren't implemented correctly or not implemented at all. And we don't want to get into a situation where there's finger pointing, but I guess what advocacy do you do to work with OEMs to go, you should use this security feature in this way and not change it, because then bad things could happen?
Yeah, we work with our OEM customers very closely, and we provide on-site help to sit with their staff, and we do code reviews of their code when they let us, and really are working very closely with them. Also, this is not a sales job for Phoenix, and I don't want to make it that.
Sure.
We provide a bunch of services out there that add-on features that we'll do pen testing and security testing and code reviews and that kind of thing that go for anybody, but they go well beyond that kind of thing. But I think the other firmware vendors are probably doing the same thing. But anyway.
Yeah, it has to be a collaborative effort, right? And I think we've seen where that falls down in certain cases where whoever's downstream is their implementation didn't consider all the security use cases, right? I think you mentioned an example, Dick, about it was on these specific systems. I wish I brought up the article, but these systems that were like an instant boot Linux was the goal. And it was the image that you could swap out for the splash screen that was one of the attack vectors. I think that's
I won't go into any details because a lot of that is still, still embargo and potential 0-day kind of thing. But this was an OEM add-on that just wasn't well thought out, and it turns out once it was brought to the fore that a lot of people made the same mistake. They decided to put up splash screen capabilities during boot and decided that they wanted more flexibility than the default that was provided by the firmware vendors. So they just pulled down an open source rendering package and grabbed any image off the disk and put it up on the splash screen. And that open source tool that rendered the images was vulnerable. And nobody checked it, nobody reviewed it, nobody tested it until it got out into the field. And oops, some security researchers, thank goodness, and not the bad guys, went ahead and found the problem and reported it, and it's in the process of getting fixed. Yeah, I would like to, if I could, just along those lines, I want to give you a real example of the complexity of the supply chain and the difficulties with putting particular embargo limits and announcing, vulnerabilities, et cetera, and some of the issues we deal with. Very quickly, I guess something like 6 or 8 weeks ago, a security researcher notified the open source Tiano core group that they had been doing, I believe, just code reviews and had found a group of vulnerabilities in one particular section of the open source code that everybody uses. I put everybody in quotes because most people use.
Sure.
And they reported it to all the appropriate folks, and it was put under proper security embargo because it's a vulnerability that could be used by bad guys potentially. There was no proof of concept. There was no actual attack against it, but it was, something that was potentially an issue. The Tiano Core InfoSec team looked at it, said, yep, we need to work on that. It's definitely broken. And it's an open source volunteer group. So it took a while to find the right people, the code owners, to take on fixing those related vulnerabilities in that one particular code path. As usual, the security folks, the researchers that found the problem, they want to get their kudos. They want to do the thing. They're motivated to get out there and say, look how clever we are. We found this and we reported it and we did it the proper way. We notified the right people and we gave them like 90 days. So they're going public in 90 days with this. And the problem was, of course, finding someone to fix it. Getting it fixed in the source code, testing it thoroughly at the open source code level. Then it needs to get handed off to the firmware vendors. The firmware vendors need to pull it into their code base, test it, make sure they didn't break anything, then roll it out to the ODMs and ODMs. They need to pull it into their code base. Then they need to build firmware images for thousands of at least hundreds and probably thousands of different machines, SKUs, because it's in everything. So they need to develop firmware updates for thousands of different machines across the industry. And those need to get pushed out to customers, or customers need to go find them, or whatever the possibility is. And it's going to be probably another 6 months after the bugs are fixed and tested before a reasonable amount of people start getting the updates in all these machines. But probably, I'm guessing, I have no stats on it, but probably only half of the people out there in the world with machines that are affected will actually update their firmware.
Yeah.
So millions and millions and millions of computers out there will be potentially vulnerable to this. But probably 6 months before even they have a chance to install the fixes, the guys were going to go to a conference and describe in gory detail the bugs they found. And so all of the guys out there in the bad guy black hat world, and I'm talking black hats, not the conference, but the bad guys, will have at least 6 months for 0 day. And probably because we don't make it really easy for everybody to do firmware updates and explain to people why it's important to keep their firmware updated, then there are going to be millions and millions of machines that have the potential of 0 day attacks. And this is what really scares me and the thing we need to fix.
So it's interesting. I want to talk about earlier in the stage where the reference implementation is vulnerable, and then it has to be fixed by all the ODMs and OEMs, and then they have to push it out. That's different from most other types of software, Dick, right? I mean, you've been doing software
Absolutely.
for a long time. I think it's different. Like Microsoft can push out a Windows update. If there's an open source library, it gets fixed, and we update our Linux systems. That process seems a little easier, maybe a lot easier
Absolutely.
than firmware, right?
The problem we have here is if I'm an app developer, and I don't want to use anybody's name, but just, as a good example, but if I'm an app developer and somebody reports a potential vulnerability in my software, I can fix it and push it out to customers as an update immediately. If it's software as a service kind of thing, it's on the web, I can just take down the current version and put up a new one a few minutes later. You can fix it in a matter of minutes. But firmware, on the other hand, is tied to the hardware, and we've gotten better. Used to be that you had to just periodically go to your OEM's website and realize, oh my goodness, there's a firmware update, download it, install it, came up with all these scary messages. And occasionally, if you did something wrong or the OEM did something wrong, you bricked your machine and you were, and so it was really scary, et cetera. Well, now in the Linux world, the Linux firmware update service is pushing out stuff to people, and Windows Update is pushing out to Windows users, et cetera. But that still only covers probably less than half of the people will accept those firmware updates.
Right.
Well,
yeah. Even what I love is, I was just going to say with ZenBleed, it came from my Linux distribution as part of the kernel, and it applied the microcode update and fixed ZenBleed. I was like, oh, that's really nice. I mean, it's not going to happen all the time, but that's one use case where it does work very nicely. But when we talk about UEFI and those components and that firmware being updated, it's a laborious process. But also, hold on, before you get to Scott, I also want to make sure we hit on, and I want Dick's answer to this question. Why do you think people are not applying the UEFI updates to their PCs? I guess two parts, one in the enterprise and one for consumers.
Enterprise has much better generally, but they generally delay because they're afraid that the firmware update is liable to mess up a machine. It rarely does, but it's not impossible. So they want to test first, just like they delay updates from their OS vendor, et cetera.
Operational risk, sure.
Yeah, sure. There's definitely risk there. End users, it's both they don't get the word or they're just scared. We've been always, every time you do a firmware update, you get those scary messages of don't unplug your computer, don't turn off your computer,
Scary.
And there is a history there where people who've been in the industry for a while have always had some experience, or their neighbor has had an experience, or whatever, a coworker, where they did a firmware update and it was a disaster.
Right.
Those rarely happen anymore, but it's not impossible. But that's why people don't install them.
Scott.
I was just going to pile on with the example you gave was a good example of ZenBleed, but on the flip side, you have something like Black Lotus, where Microsoft can push and revoke the certs for those vulnerable bootloaders that malware campaign used. But what they're not able to fix is the underlying vulnerability in Secure Boot that was exploited for the first time in the history of Secure Boot in 2 decades, where you now have this vulnerability called baton drop that effectively becomes almost a forever day, to the extent an attacker can bring an arbitrary vulnerable bootloader with them to the attack. So now, as long as you can do that and you're ahead of Microsoft's ability to revoke, then you're able to bypass Secure Boot. And I feel like the industry still hasn't kind of got their head around the idea, kind of to both of your guys' points, that this is not a Patch Tuesday situation, right? That you can revoke via that method. That's awesome. And it might help in the short term against a certain campaign. But now you have Red Lotus, now you have Black Lotus being written in Rust. There's going to be Go versions of this. And baton drop as a vulnerability in Secure Boot itself, architecturally, that's not going away anytime soon, right? And that's the kind of the problem we have to worry about. Talk about a long tail.
Yeah, I'm not an expert on baton drop specifically, and I've generally, have said that we haven't had many vulnerabilities that are driven from the specification. They're usually poor implementation. this is one where, that crosses over a little bit, but it can be mitigated in firmware. So a firmware update can make this go away. But yeah, again, I don't want to speak out of turn on it because I'm not an expert on that particular one. That was brought up to me by the guy from CISA, Jonathan Spring, just a couple of weeks ago, and we were talking about Black Lotus and revocations and stuff, and he said, "But baton drop," and I said, "Yeah, I need to study up on that one a little bit more." So
yeah, well, you nailed it, and it's all to your point that even if there is a firmware update for it, it's got to be across all vendors, all implementations, all models. So yeah,
and that's exactly the problem with the one that I mentioned that I used in my long example there is exactly the same issue. Is it applies to pretty much every machine that exists on the internet that uses typical UEFI conforming firmware. It probably affects at least 95% of the machines out there right now, and they're going to talk about it in early December, and that those machines are not going to be patched. Even though patches are available, it's got to funnel through that long supply chain that we just described.
Just in time for the holidays.
Yeah, and I think also, Dick, we have to talk about the operating system vendors being part of this, a piece to the puzzle, right? Because now our conversation is kind of going to that, and certainly we've seen the Windows platform binary table be used, which was supposed to be a legitimate usage in a standardized way for UEFI and the operating system to communicate with each other, but it also gets abused as well. So what's it like to, from a security perspective, working with different operating system vendors, right?
It's very it's a good collaboration at this point. We're all working towards the same goal, and we're trying to speed up the process. So I haven't had any difficulties at all dealing with OS vendors. The Linux Foundation has been a member of UEFI for many years, and even though they're not one of the founding members of the organization, Red Hat has a representative on our security response team, that sort of acts as a point of contact into the whole distro world out there. But we had every event we have where we do testing, and the event we had 2 weeks ago, where we did a lot of developer conference and Plugfest testing environment. We had Microsoft and some of the Linux vendors, et cetera. We were testing the Black Lotus revocations and new keys and that kind of thing on all the machines present. So it's a collaborative environment. I don't see any negativity there at all.
Yeah, that's good, because I think, as we established, everyone's got to work together if we're to fix, especially the security problems that we're trying to address, for sure.
Absolutely. I haven't found, honestly, it's usually a resource issue. Mm-hmm. We know about something we need to work on, or secure or whatever, and everybody's got tight budgets, and engineers are actively working on new features and stuff, and it's some security is sometimes seen at least vulnerability management going back into code is seen as, oh, I don't want to do that. That's the old stuff. I want to work on all the new flashy stuff. So getting resources assigned to work on stuff can be a challenge, and open source communities and in specification groups, et cetera.
Is there does the skills kind of gap, or it's hard to find people to work on this stuff, I would imagine. There's only so many people in the world that are working on UEFI in this firmware level code, correct? Is that still an issue?
It's a small community. At the event last week, it was a lot of the same players that were present in the room, but many of them work for different companies now. It was kind of old home.
Yeah.
Everybody shifts around from one company to another, but it's the same faces all the time. But that's not entirely true. We're bringing up new people into the field all the time, hiring new folks and converting engineers that have been doing product development into the security space. And I think an important part of it you mentioned in your intro of me is I spent 10 years as a college professor teaching computer science, upper division of the undergraduate work. And I thought, and I feel today, that teaching security issues is an incredibly important part of the university experience. Teaching the mentality of security and secure by default and general secure by design approaches to software development and firmware development is critically important. And we're doing a bit of that, but I think we could do more.
Agreed. Dick, anything else you want to evangelize for our audience today?
I think that we need more input on this SBOM thing I've been talking about. Right now, it's a relatively small group of folks, and I would really love to get more people involved. And since we're not developing specifications as such, we're really kind of developing guidance for the industry, participating both at our level at the UEFI Forum, and also CISA has four or five working groups on SBOM delivery and format and et cetera, tools, et cetera. Engaging at that level would be critically important for folks. And those are all open. Anybody can join in. Just go to the CISA website. And if you're any kind of member of UEFI, if you're interested even at the adopter level, since we aren't talking specifications at this point, there's no intellectual property issues and those kinds of things. We can invite people to join us.
Fantastic. Well, Dick, thank you so much for appearing on the show today. And that will conclude this episode of Below the Surface. Thanks, everyone, for tuning in. We'll see you next time.